Okay, so third method for solving systems of linear equations. We did graphing. We graphed and found the point of intersection. And then we used substitution instead of graphing. So we got one equation so that it was in terms of the other equation, and then we substituted and we found the x and the y. And we said that was still going to represent the point where they crossed. We're just not seeing it visually because we weren't graphing it. And then now we're going to use elimination. So elimination is what it sounds like. We're going to eliminate something. So you get to pick which variable you want. Just like you picked in the substitution problems, you picked what was the easiest variable to get by itself in one of the equations. You're going to pick which is going to be the easiest to eliminate. So there's going to be 3 stages of difficulty. One of them is easy. If you look here, these will already eliminate each other if I cross out. These will make an 8y, right? Those will not go away. But if I add these together, those are going to make 0 and it goes away. So this is the easiest possible problem in the elimination section. They're already set up, these x values, to be opposites, so that when I add the 2 equations, I combine like terms, this cancels out completely. That's gone. So then when I combine like terms here, I get 8y. And then I've got the equal sign. Combine like terms here, I've got 16. So I'm going to solve for the y. I'm going to get the y by itself. I get y equals 2. And then just like all of the other problems, we need the x value as well. So we're going to go back up anywhere at the top that has both x and y. It doesn't matter which one you choose, one of the original equations. And you're going to plug the 2 in. I like this one better because it has smaller numbers. I don't want to deal with a 5 and a 10 when I can deal with a 3 and a 6 instead. So I'm going to take this original equation, 2x plus 3y equals 6. I'm going to replace the y with a 2. Everything surrounding it's going to stay the same. There's a 3 being multiplied in front. There's a 2x being added all the way in front. And I'm just going to solve it like an easy algebra problem. So if I subtract 6 from both sides, I get 2x equals 0. And then divide by 2. 0 divided by anything is 0. And then just like always, you guys know I always like to try and show you a common mistake of writing the y first because you found it first, but you all know points show up with the x first and the y second. So that would be where those 2 points would cross each other on a graph, the point of intersection. The next level of difficulty is none of these are opposites. If I combine those, I would get 8x, and if I combine those, I would get 5y. So none of them are going to eliminate automatically on their own. So I need to decide what can I do to get them to eliminate. So I see here, this is a positive 4. If I multiplied that by a negative 4, they would cancel out. This would be a little more tricky. There's nothing I could multiply just one of them by to get it to equal the other. So I'm going to take this first equation and multiply everything, the entire equation, that's what I have to do to keep it balanced. I'm going to multiply it by negative 4. So when I distribute, I have negative 12x minus 4y equals, and then negative 36. Now I have, with the other equation, I have a positive 4y and a negative 4y. Those will make 0 when I add them together. So if I add the like terms, that's going to go away. 5 minus 12 is negative 7. 22 minus 36 is negative 14. Divide by negative 7. X equals 2. And just like always, we need to plug it back in. I can go anywhere that there's an x and a y. This looks like it's got the smallest numbers. So I'm going to take that first equation again, the original equation before I did anything to it. I'm going to replace the x with a 2. Everything around it stays the same. I'm going to subtract 6 from both sides, and I get y equals 3. So x comma y is my answer. The last, so on this one I didn't have to multiply anything. They already canceled out. They already made 0. On this one, the original equations, neither of the x or the y would go away, so I had to multiply one of the equations to make the y's go away. On the next example, there's nothing I can multiply this by to make it a positive 5, so it would go away with this. And there's nothing I can multiply this by to make it a negative 2, so that it would go away with that, or cancel out with that. Same thing with the y's. There's nothing I could do here to make this a negative 8, so that these would cancel. And there's nothing I can do here to make this a positive 9, so that those would cancel. So in this case, I'm going to have to multiply both equations. So there's three, like I said, there's 3 levels of difficulty. One of them is you don't have to multiply anything. They all cancel out, or the x's or the y's cancel out on their own. The other one, you have to multiply one equation, and then the most difficult, you have to multiply both equations. So you choose. You can choose either the x's or the y's. It doesn't matter. So if I have to choose between dealing with 9 and 8 or 2 and 5, I'm going to deal with 2 and 5. So I want to think of the least common multiple of 2 and 5. So what's the smallest number that both 2 and 5 go into? That would be 10. So to get a 10, I'm going to multiply this one by 5, and I have to do the entire equation by 5. To get a 10 here, I have to multiply this one by 2. And then notice this is going to give me a negative 10, and this is going to give me a positive 10, so that they'll cancel out. So that'll be nice. Sometimes you might have to multiply by a negative on one of them, so that one's positive and the other's negative. So the top equation, when I distribute the 5, gives me that. The bottom equation, when I distribute the 2, gives me that. Now these will cancel. Just that's our goal. We want to get opposites. So positive 10, negative 10. Or on the first one, positive 2, negative 2. Or on the second one, positive 4, negative 4. So what is 45 minus 16? Negative 45 plus 16. Gives me that. And again, dividing by 29 or negative 29. 0 divided by anything is 0. And then I can plug in anywhere that there's an x and a y. So I could choose any of these 4. It doesn't matter. So I'm going to go with the one that has the smallest numbers, just like always. Top equation. And I'm going to plug in the 0 for the y. Everything around it stays the same. 0 times anything is 0. So that makes a 0. So x equals 4, dividing both sides by 2. So the solution is 4, 0. Let's do one more like this, because I feel like this is a little bit tricky, just so you can see it. One more time. So take a minute, write this down. Take a minute, I'll have the sub pause the video right now. Talk to someone next to you and see if you can pick. First question is, do you want to cancel the x's or the y's? Which one's going to be easier? And then the second question is, what would you need to multiply the top and multiply the bottom by to achieve that goal? So go ahead and pause it real fast. Okay, so hopefully you answered that question. I don't want to deal with a 13. No, thank you. I would rather deal with a 2 and a 3 than a 13 and a 4. So I need to think of what number do 2 and 3 both go into. 2 and 3 both go into 6. So they both go into 6 and 12 and 18 and all of that stuff, right? But we want to deal with the smallest one, so 6. So I'm going to multiply this top equation by 3. And I'm going to get a negative 6y here. And I'm going to multiply the bottom equation by 2 to get a positive 6y. So notice again, I'm looking for one of them to be negative and the other one to be positive of the same number, or opposites of each other, so that they cancel out. So when I distribute on the top equation, 3 times 13x, and then distributing and multiplying the 25 times 3. Common mistake, people get so wrapped up in this and thinking about what they should be multiplying by, they forget to multiply on the right side also. Remember, you have to balance your equation. Anything you do to the left, you have to do on the right. So, and then distributing on the bottom. These numbers aren't very pretty, are they? So 39 plus 8, is that going to be 47? That's going to be 47, right? Yes, so it's actually not that nice. I mean, not that bad. So again, these cancel out. This is our whole goal in the entire problem, is to get those to cancel out. And we did that. So we did 47x, those made 0, and then that became 47. Dividing both sides by 47 gives me 1. Picking which equation is going to be the easiest to deal with to find the y value, I'm going to use the second equation because it seems like those numbers are nicer. I'm going to replace the x with a 1. Everything surrounding it stays the same. This step we've done 1,000 times, I think. Maybe not quite 1,000. Subtract 4 from both sides. Be careful with your negatives. Subtract 4 and then divide by 3. So that is elimination. So hopefully that's good for you on your con and your homework tonight, and I will see you tomorrow.